that going?
Hey, ladies and gents, happy New Year to you all. Thanks for coming along tonight. So today we have a couple of speakers, so James Philpotts and Tom Spencer. First up will be Tom, talking about the rest for the whippet. And then after the break, there'll be James Philpotts talking about share all the things. There'll be a short break in between two talks. If you haven't been to Bristol before, the format is 30 minutes of questions and then a short break, and then another 30 minutes and follow-up questions. And then if all goes well, the pizza will arrive at that point, and there'll be food down the other end. Obviously, we do have beer tonight, so help yourself to the beer. There's also wine and some soft drinks. But obviously, enjoy the talks. If there is a fire, then it's back out the way you came in. There's actually a fire exit also at the rear. Okay, so without any further ado, over to you, Tom. Thank you.
Do you want me to show the Vox days?
Okay.
Okie dokie. Well, thanks for coming along, guys. My name's Tom Spencer. I'm a full-stack web application developer, mostly doing JavaScript stuff these days, and I'm just going to talk a bit about RESTful APIs. So this is no rest for the whippet. It's got a few dogs in there. Might have got the joke, no rest for the wicked. It's a pretty bad one. There you go. Okay, so as I said, that's me, next to Fernando Alonso and Sebastian Vettel at the Melbourne Grand Prix in 2014. But when I'm not racing F1 cars, as I said, I'm a full-stack web application developer. I've had a fair bit of experience building APIs with Node.js and also consuming them as well with JavaScript and AngularJS. So I'm just going to run through a little bit of that today. So why build an API? Well, really, the answer is to provide your data to everybody, to all the consumers that hope to get a hold of your data. So the world is kind of changing, I guess, whereas once upon a time we might have logged on to our desktops or laptops and gone onto websites that were kind of monoliths, if you like. All of the data was in there. We're now accessing data through phones. Mobile phones are quite prevalent now. I'm guessing pretty much everybody in here will have a smartphone. And also Internet of Things as well, so that is going to become quite a big thing. There'll be lots of connected machines talking to each other, and APIs are really the key to be able to handle data exchange there. So in particular, I'm talking about RESTful APIs. Just a quick show of hands, how many people have had experience consuming a RESTful API? Okay, that's the majority of the room. How about building a RESTful API as well? Okay, I guess that's probably over half. So my apologies to some of you. This might be flogging a dead horse, so we might be talking about stuff that you already know. I will try and whittle through some of the concepts fairly quickly, and I'm hoping to have a bit of a Q&A session at the end and just have a bit of a chat about API design and your experiences with it and that sort of thing. But just at a very basic level, so what is REST? Well, REST stands for Representational State Transfer, which I always mess up, not that time maybe, but that's why most people call it REST. It's a bit of a mouthful. What it is, it's a very strict set of rules really that governs client to server communication. It's a specification, if you like. It's quite a large one as well. There's kind of lots of stuff in there. So what I like to do is look at REST as a guide really, and be quite pragmatic about designing an API with RESTful principles. In other words, not being a Restafarian. Sorry. So, as far as I'm concerned, building an API is mostly a design problem. The engineers and the testers in the room will be shouting at me, I'm sure, and saying, building an API is actually quite a hard thing to do from a technical level. Yes, it is. I completely agree with that. But I think if you spend a little bit of time designing your API up front, then you might save yourself a little bit of headaches down the road when you're developing and testing it. So, okay, that's great. So how do we design an API? Well, the first thing I tend to look at is the data model itself. So if you're lucky enough to be building a kind of a new project, a greenfield project, then you might be able to design your data model, from scratch, which is great. But if you're not quite so lucky, then you might already have a data model that you need to expose via an API, and that's all about kind of studying it and seeing what you can glean from that. But once you understand the data model, trying to represent each model as a resource is the next way to go. So by a resource, what I'm really talking about is URLs. So again, at its core, API design is about designing URLs to access and manipulate resources. So at a basic level, that's CRUD, create, retrieve, update, and delete. There are also other cases where you might want to step out of that box and not necessarily do CRUD style manipulation. You might need different actions, but we'll talk about that in a bit later. So the next thing I'd aim to do is to look at getting our URLs for our resource, and I try and aim to just have 2 URLs per resource. So the first URL, let's take a data model dog. The first URL, I would take the plural form dogs, so /dogs, very simple. The second form would be the singular form, so that would be /dogs with an ID after it. By using these 2 URLs, and we'll look at some HTTP methods in a second, you can get your full suite of CRUD manipulation. Notice that I'm using the plural form dogs over the singular dog. It's semantics really. Some people would use the singular form, but I prefer to use the plural form just because it's kind of a bit more obvious what's going on. Okay, so we've got our 2 URLs for our resource. So the next part of the recipe really is HTTP methods. So by combining HTTP methods and URLs, as I said before, we can get our full suite of CRUD actions. So let's look at some examples. So again, we've got our resource, which is with our 2 URLs, dogs and dogs/ID. Our first HTTP method is a post. So that is analogous to a create in CRUD world. So what would happen if we combined post with the plural form dogs? Well, that is creating a new dog. What about sending a post to the singular form dogs/1234? Well, that kind of doesn't really work. Most of the time when you're creating something, the server is normally in charge of creating an ID for you. And so by predefining your ID and asking the server to create it with this ID, it's kind of not really the way to go. It doesn't really work. So that's actually an error. So that's creating. The second one is get, which obviously corresponds to a retrieve in CRUD. So by issuing a get request to /dogs, what do we get? Well, we list our dogs. We get all of our dogs. So we can also reduce the amount of dogs that are returned. If say we've got 10,000 dogs in our database, we might not want to retrieve all of them at once. And so we can do things like filtering, pagination, to reduce the number of dogs that are returned. We can also do things such as sorting as well, which manipulates the order in which they're returned. We'll talk about that in a second as well. The other form, the singular form of the URL, issuing a get to that would get a single dog, so that's with an ID. We do also have to be mindful there that that ID might not exist, so we have to also account for that case on the server. Next up, we've got a put, and put corresponds to an update in the CRUD world. Putting to the plural form dogs, well, that's batch updating all of our dogs, or batch updating the dogs that we want to update by ID. It's maybe not as common a form as the singular form, but it is certainly possible if you want to do a batch update. As I said, more common, you would want to update a dog, a singular dog, by its ID. And lastly is delete. So delete fairly obviously corresponds to a delete in CRUD world. Again, we can combine delete with the plural form dogs to kind of delete all dogs or batch delete dogs. Maybe a little bit dangerous doing that, which is why it's in brackets here. It might not be the best thing to do, but technically it can be done, and it is kind of allowed in REST. But more common is probably the singular form, where you're just deleting a single dog. So you can see here from this quite simple graph here, by combining our 4 HTTP methods and our 2 resources, we get this kind of whole suite of CRUD actions, which is quite nice. So you'll notice that the URLs that I've been using, they're all kind of noun-based. They don't have any verbs in there. The verbs are the HTTP methods, and that's kind of the cornerstone of REST, really, trying to keep verbs out of your URLs. So for example, this would not be a RESTful URL because it's got verbs in there, get all dogs. Instead, as we've just seen before, we'd use an HTTP method along with the URL. Similarly, very, very similar example there, getting a dog by an ID. On the left-hand side is the kind of bad way of doing it, or the non-RESTful way of doing it, shall we say. And the right-hand side is the more RESTful way. And the last example is a create, which, as we've just looked at, is a post. Okay, so that's cool. So we talked about requests, but what about the responses? So there are 3 main types of response that the server could issue to one of your requests. The first one is everything's cool, everything's okay. We accept your request, and we've done something with it, and everything's all right. The second response is, I'm sorry, client, you've sent me something that I can't do anything with. So the client did something wrong. And that's something where the client would look to take some action to change its request in some way so that it can be allowed on the server. And the third response is the server did something wrong. So this is something that the client can't really fix. The server might be having a meltdown, it might be unavailable, something might be wrong in the database, could be anything. So typically there the client is kind of probably just going to have to wait for a little while and hope that the server comes back up at some point. And we represent these responses using status codes. So the everything's okay status codes by RESTful definition start with a 2, the client did something wrong, start with a 4, and the server did something wrong, start with a 5. So just looking at those in a little bit more detail. Everything's okay code. So the 200 OK code is probably the one that is most commonly used, probably the one that most people here are familiar with. So that's a kind of a catch-all, everything's okay. I guess you use that when no other 2XX codes apply. You can just use that exclusively as well, really, as your everything's okay code, and many APIs do this just for simplicity, and that's absolutely fine. There are other options that you could consider. The 201 is a created code, and that is fairly often used when you created resource, so really that only makes sense with the post to this plural form dogs. Request to create resource was successful. The 204 is another possible as well, and that kind of indicates no content, so you might use that when you're deleting a dog. So you've deleted the dog from the server, you have no content anymore, so there's nothing really to send back to the client. Some people might argue that you maybe want to send a message back to say, yep, you've deleted it, in which case you might use a 200 at that point. But 204 is very possible. So there's something wrong codes, 400. So I often use the 400 as 400 bad request for validation error. So when you're creating or updating a dog, you pass some invalid data, then the server might choose to pass back a 400, at which point the client will need to take some action to remedy that data and send it in a valid format. A 401 unauthorized, so that's used when the client needs to supply credentials, when you need to log in, essentially, when you need to authenticate to access the API. So the client would then typically use that status code to say, okay, I need to add some sort of credentials to access this resource. 404 very commonly seen on the web, not found, resource does not exist, so that might be requesting a dog that doesn't actually exist by ID. So those are the main three client codes, the 4 codes. The main server code is a 500 server error, which just kind of says the server threw an exception, or the server something has gone wrong on the server essentially. And that's something that, as I said before, the client might need to wait for a little while before trying that request again. So that's a really small subset of HTTP status codes. There are tons more, but I prefer to keep it as simple as possible, really. I mean, to be honest, even the 2 codes there, you could probably just condense that down to a 200, really, if you wanted to keep it really, really simple. I think simple is better than trying to adhere strictly to REST. If you to do that, then you'd have to use a myriad of status codes, which can get confusing. So what about the actual format of data? So we talked about requests, we talked about the responses, but what about how to structure the data? Well, really, I would suggest to use JSON. XML is kind of available. You can use it if you want to, but I find JSON to be much less verbose. It's very well supported across a multitude of different languages, different devices. Whichever language you're using to consume an API, chances are you've got a JSON library there to process and parse it, so I would suggest to use JSON. So for example, a simple request to get dogs would look like this in standard JSON. Okay, so that's kind of the theory, so I'm just going to whistle through some examples really, really quickly. So retrieving. Retrieving is the kind of largest subset of the CRUD actions, really, because you can retrieve all of the dogs, you can retrieve them by ID, but you can also filter and paginate as well. So we'll briefly just touch on that. So getting all the dogs, what would that look like? So as I said before, we'd issue a get HTTP method to the plural form dogs, and we'd receive some JSON back, 200 OK, and here's our dogs. What about a single dog? So getting a dog by ID. So our URL would be used in singular form. We'd use the get method again, and we get a 200 OK. This time, a single entity has been returned. So this is a JSON object, while previously it was a JSON array. There was a single dog. What about if we pass an ID that doesn't exist? So 4321 doesn't actually point to a valid dog, so what do we get back? 404 not found. Okay, so filtering of dogs. So you might have a lot of dogs on the server, as I said before. You might only want to fetch some dogs. You could, I suppose, fetch all of the dogs in the server, and then on the client side, decide which dogs you like, which dogs you want to keep, and which dogs you want to throw away. But that's really quite bandwidth intensive and not a very good way of doing it. Instead, it's much better to add some rules on the server side that you can use to filter your dogs. So let's say you want to get all of your dogs dressed in a costume. Why not? So how I would implement this is through a query string parameter. So dress equals costume, and we get our friend Heinz, who's dressed in a nice hot dog costume back. Okay, so how about pagination instead? So we still want to retrieve all of our dogs, but we don't want to retrieve all of them at once because there's loads of them. How about just retrieving dogs 1 and 2? Well, I would go about this by using the offset and limit query string parameters. So by setting offset at 0, we're saying start at the beginning, and by setting limit at 2, we say limit this to just 2 dogs returned. So let's see what we get from that. We get our 2 dogs back, which is what we expect. How about dogs 3 to 10? Well, in that case, we'd again use our offset and limit parameters. We'd offset by 2, so we're starting at the 3rd dog, and we would limit 8, so that gives us dogs 3 to 10. And in this case, we've only got 2 dogs on our server, so nothing returned. So I've chosen, interestingly here, chosen to use a 200 OK rather than a 204 no content. There is actually no content that's been returned, but you can kind of also argue that there is content being returned. It's an empty array, so I kind of choose to use a 200 with an empty array here. In any case, there's no dogs on the server, so that would return nothing. Okay, how about sorting our dogs? So that's something else that databases are pretty good at. If you've indexed particular properties on your data model in your database, then the database is very efficient at sorting. So we can leverage that by providing sorting options for our query string. So let's say we'd like to sort by name. So we use, again, a query string parameter, sort equals name, and we get our dog sorted by name. So that's ascending alphabetical order. If we're looking for reverse alphabetical, descending, then we can choose to use exactly the same method, really, a query string sort, but I tend to like to put a minus in front of the name, which kind of indicates this is a descending order instead. And then we get our dogs in the other way around. Okay, so that's retrieve, really, in a nutshell. So the next part is create. So creating a dog, as we've seen before, creating a dog is fairly simple. We're posting to the plural dogs endpoint, and we're sending in our request body the data that we want to associate with the new dog. So let's say we'd like to create Santa's little helper. Notice here that there's no ID involved at all either. So we're again asking the server to create an ID for us, which is very good at. There's no point in the client trying to do that. I've chosen here to return a 201 created, and the server gives us the entire resource back as well. So it gives us both the ID and the name, it echoes that back to us as well. So that's kind of one of the RESTful principles there, by echoing everything back to you. I mean, you could argue that for bandwidth constraints that all we really need back is the ID, because that's the only thing that's been created by the server. We already have the name, but REST guidelines kind of say it's probably better just to send the whole thing back, so that's what I tend to do. So what about if we ask the server to create a dog, but there is something wrong with the data that we've sent? So let's say we need a name. Dog needs a name. We can't have a dog without a name. But if you try and create a dog without a name, what should happen? Well, in this case, I would send back a 400 status code, which corresponds to the bad request. And I'd also give a bit more information as well. So I give an errors object, which tells us which field was in error. What kind of constraint violation happens, so in this case it was a required validation, and also a message as well, which could possibly be used in the UI if this is being used by a UI. And by offering an errors array rather than an object, I should say, we can provide many different errors. To say there was an age that was also required, we could offer that as another violation as part of the returned data as well. So this is good because it means that the client can then take action. It knows, okay, the name is in error, this is what's happened, and then if it's a UI, we can show on the UI this particular form field needs to be filled out. I think it's also important to note that this sort of thing, if you're building a UI, can actually be done on the UI as well. But it's best not to rely on just client-side validation. Also, having server-side validation in there is quite important in case somebody decides to bypass your UI and try and post directly to your API. Okay, so that's great. So next up is an update. So updating a dog. So updating an existing dog is the first thing we'll look at. So that's the singular form. So let's say we'd like to change the name of our dog to hot dog. We've got the ID there on the URL, so we're identifying that particular resource. And RESTful principles again to us to send the entire data back along with the 200 OK. So we get our ID and our name hot dog. That's a very good point, actually. Yeah. So patch is, I guess, a more modern way of sending partial data. So typically a put is used for your entire resource. So if you wanted to update just the name and say there is also an age associated with the dog, date of birth, etc. If you just wanted to update the name, then you could use patch, absolutely, and that would be a kind of a RESTful principle. I tend to take the more pragmatic view and use put in that particular instance, just because there are certain situations where patch isn't necessarily supported by some consumers. But certainly, if you're confident that all of your consumers support patch, then that would probably be a good way to go. Yeah. So batch updating dogs, very similar. We send to the plural endpoint dogs, but we include the IDs inline in the body there, and we send a JSON array. So in this case, we want to update both of our dogs on the server, and again, we receive our dogs back, which is great. So as for a create, we also need to handle the case where data, it might be invalid that we're being sent. So again, a validation error may occur if the name is required, and we get the same response back in that case as we would have done for a create. So dog not found is the last thing I guess to talk about in updating a dog. This is the same as when retrieving a dog. Because we are using the singular form of URL, it's possible that dog doesn't exist. So by sending to a ID that doesn't exist, we will get a 404 not found back. So that's updating. So deleting is the last part of CRUD. So by deleting an existing dog, so again this is the singular form, passing the ID on the URL, we've chosen to return a 204 no content in this case because there's no dog left on the server. Poor dog. We also need to handle the dog not found case as well, which again we'd send a 404 back. So that's CRUD. That's kind of your basic API actions, I guess. But what about if you are looking at other actions, things that don't necessarily fall into your create, retrieve, update, delete mechanism? So some actions can't be represented RESTfully in that case, so we have to kind of break the mold a little bit. For example, how to tell a server to walk the dog, which can happen in some parts of the world. In this case, I would break the rules and use a verb. So I know I said don't use verbs earlier, but this is one of those cases where it's probably best to use a verb. So let's have a look at how we would model walk the dog. So we would use a singular form to start with because we are referencing a particular dog. So we've got the ID in the URL, but we'd add a verb on the end, walkies. And I tend to use post to reference any of these other actions that kind of don't really fit into your CRUD. So posting to this particular endpoint, we might get something back that says Fenton is now walking, and we get a nice YouTube video as well, which if I can move my mouse and start this up, we all know and love. It's nothing without the sound.
Fenton! Oh, Jesus Christ! Fenton! Oh, Jesus Christ! Fenton!
Every time. Okay, so I kind of talked about the basics, I guess, really, and I'm sorry for those of you that are falling asleep because you already know this. What I'll try and talk about now is productization side of an API. So by this, I kind of mean preparing your API for the outside world. So it's all of the stuff that needs to go on to support your API, to make sure that your server doesn't go down, make sure your users know how to use your API and access it in a particular way. So the first thing to consider is authentication. So authentication is all about identifying who is accessing your API. And by this, I would argue to use a token or ask the consumer to use a token to access the API. This, I guess, kind of fits in with RESTful principles that things should kind of remain stateless. So sending a token with every request, there's two suggestions. So the first one is an API key. So that's asking the consumer to acquire an API key from you as the API developer, and to provide that on every request to identify who they are. The second is OAuth. So OAuth 2 is a protocol which kind of automates this, and James will be talking about that in a lot more detail in the talk after me. It's important to note that if you do require authentication on your API, to handle the case where somebody is not authenticated, and I would tend to return a 401 status code if the token isn't valid or the token doesn't exist at all. So very quickly, API keys, I would choose to send those as a header. You can call the header anything you like, really. You tend to use X-access token. And so it's the consumer of the API's responsibility for adding that token on every request. The advantages here is very simple for you as an API developer anyway. It allows you to identify individual users, so each user or consumer of your API will have a different key, so you kind of know who's accessing it. But the downside is the API consumer must acquire the token manually, so they must physically somehow get a token from you, whether it's through your admin portal or through email or what have you. They then must add it onto their API request manually as well. The other option is OAuth 2. So OAuth 2 is a fully automated token exchange, so it removes the burden of the API consumer to cut and paste that API key and put it into their library, into their SDK, or into their app when they're consuming your API. Instead of that, the OAuth window will pop up, so you might say, acquire a token for me. You, as a consumer, you then use your OAuth details. You might use a separate provider, such as Google or Facebook or Twitter, so you might use your Facebook identity. Your API server can then hit the Facebook server and say, I've been given these credentials, can you give me a token, please? So it starts a handshake. James will be talking about this in a bit more detail in the next talk. But suffice to say, the good thing about this is all the user has to do is remember their email and password, which could be even worse than asking them to get an API key depending on the user. But the idea is that it's fully automated. And again, you can identify individual users because they've logged in and they've used their own particular details. But it can be quite complex. You might need to build or integrate into an OAuth server. So there's really a bit of a trade-off there. Would you prefer an easy life for you but a harder life for your users, or the other way around? It's a bit of a trade-off, really. But I think authentication is a fairly important part of an API. Even if you've got a public API, it's probably a good idea to at least have an API key in there. And the reason for that is this point, which is rate limiting. So rate limiting is all about preventing malicious users, or maybe just users that don't really understand what they're doing, hitting your API hundreds of times, thousands of times a second, and bringing down your server, the dreaded denial of service attack. So rate limiting is all about preventing consumers from tying up your server resources so that other consumers can't access anything. And a very simple way of rate limiting is to tie it into authentication. So at a basic level, you track the number of requests per API key or per user for a fixed period. And if it goes over that limit, then you issue a particular status code back to that user. So in this case, I'd use a 429, which we haven't talked about previously. But a 429 corresponds to too many requests, and it's a very good fit for this sort of thing. So the idea, again, is that you track the number of requests per user. If it goes over a particular threshold, you issue a 429, which tells the client, stop sending me so much stuff, chill out for a bit, and you might be able to access it again. So that's kind of in a nutshell rate limiting. Errors. so errors will happen. We've already talked about them. There's two kinds of errors I consider. There's client errors, so that's quite often a validation error. If it is a validation error, it's really important that you tell the client as much detail as possible about what that error is so that they can take appropriate action. So as I've talked about before, this errors object is really quite handy because it tells them the name of the field that was invalid, so the particular piece of data that was invalid, why it was invalid, what type the validation error is, and a message as well that might be displayed on a UI. It's also possibly a good idea to show a developer message as well, that the developer of consuming the API can use that for extra information. If it's a server error, then sending a general failure message is generally a good idea, really. So something along these lines. And again, developer message can be quite useful as well. And last, but certainly not least, is documentation. So documentation is not the most interesting of things, but it really is quite essential if you're expecting anybody to integrate into your API. What happens if you don't provide good documentation? Well, this could happen, which nobody wants. It will take time, but it is essential. There are some tools that can help you. So there's a few here that I've listed. There are others as well. Swagger is a nice tool for allowing you it gives you a UI that users can then interact with and actually live kind of check what your API is doing, which is nice. API really is kind of a hosted similar sort of solution where you use I believe a JSON kind of markup to describe your API, and it provides a nice hosted service that users can view your documentation. JS doc is a little bit different. This involves you commenting your code, and it produces documentation for you based on those comments, quite similar. Other languages, Java doc, and other languages have this as well. And a bit of inspiration. The last sort of couple of years of integrating into APIs, I've found these three sites in particular really, really good documentation. Slack, Stripe, and Twitter. Of course, these guys are rather well-funded. Unless you work for such a well-funded company, you might not be able to provide such beautiful documentation, but I think they should be used as inspiration more than anything, just to get some guiding principles about what works and what doesn't really work. Okay, we're almost at the end. So I've created a small code tutorial as well. Anybody that isn't necessarily that familiar with REST and wants to get a little bit more involved and try out some of the principles from this talk, here's the link. We'll post the link later, I guess, as well. It's a test-driven way of going through and creating an API. So you get a bunch of failing tests, and implementing your API server to pass the tests is kind of how you build the API. So if you're interested, give it a shot, and let me know what you think. Let me know if you've got any problems or any questions, and I'll be glad to help you out. Bit of further reading. So a lot of this talk has come from these two links, really. So if you are interested in learning a little bit more, then again, we'll post these links, post these slides up so you can take a look. And that's it, really. So thanks for listening, everybody. Just wondering if anybody's got any questions, would like to share anything to do with their own experiences with APIs.
Yeah, I was just wondering, what's your opinion on API endpoint returning different data depending on the user that's hitting it?
Okay, that's interesting. Can you give an example that you might have come across?
Yeah, so maybe one user has access to some docs, and another user has access to other docs.
I see what you mean. Yeah. So different resources belonging to different people.
Yeah.
I think that's quite an important part of API design, actually. Certainly, if you're building, say, a web application and you've got user management in there, if resources are being created by one user and they are of a role normal user, then I don't think they should necessarily see other people's data. If you're an admin, so if you have a different privilege, then maybe your request to that endpoint could return more data than what a normal user would. But yeah, I think that's a really good point and a really important thing to factor in when you're kind of building your API in the server. Yeah.
So is it okay, in your opinion, for an endpoint to return different results?
Absolutely.
Shouldn't make the endpoint unique by including like this ID or anything?
I wouldn't say so. I mean, there's obviously going to be some way of you're going to have to, as a consumer, you're going to have to send some information to that endpoint to say I am this user, whether that be through a header or possibly it could be a query string parameter as well. I mean, there's no reason why that isn't the case, but I guess maybe a header might be a better option for that sort of thing. But yeah, certainly in that case, you want to look at the data that you're returning and make sure you just return the appropriate data for the request that's being sent. Yeah. Yeah.
Just to add on to that,
yeah.
That's to do primarily with separating out authentication and authorization.
Absolutely right. Yeah. Yeah.
What is around other things to use like the JWT tokens, because what you then do, you do claims inside the token, and then your client, then the server side can actually decrypt that token and get the claims out to see whether or not you're allowed to do what you want to do. The next step you don't want to do, you don't want to be going off to an identity provider OAuth 2
yes.
and saying, am I allowed to do
yes.
this?
Yes.
API server itself should be doing working out what claims are inside of that token or have them cached somehow, and then allowing that person to only see the data or have the rights that are on that token. So that's where it is. Yeah, but this is the idea when you switch, there are two paths to security. There's authentication and authorization.
Yep, absolutely right. Yeah. So just expanding on that point slightly, with JWTs, for anybody that hasn't come across them, they're kind of, I guess, a kind of a new way, would you say, of handling this information. So typically, previously you would maybe use sessions instead. So you might rely on cookies in your browser, and a cookie would have a session ID. And with every request, you would send that session to the server, and the server would then look up that session from a database table and figure out what user you are. So obviously, with every request, you've then got this overhead of hitting the database, figuring out what user they are, and then figuring out what they're able to send back. With JWT, sorry, I catch your name. Yeah. That Adam mentioned here. So JWTs, the entire information about who that user is stored in the JWT itself. It's cryptographically secure, so it's signed on the server using keys that only the server knows about. And so that when the server receives a JWT that's been encoded on the server, all it has to do is decrypt that JWT, and it instantly knows who the user is. It knows what role they might have, it knows what ID it might have, so it knows what permissions it has. So it prevents that access to the database, which is really nice for scaling. It means that everything is stateless as well, essentially, because you don't have to store anything yourself in the database and have that control when sessions expire and all that side of things. So JWTs are really, really nice. I certainly look into them if you're thinking of building any sort of authentication system.
The other key bit about those types of tokens are they're time limited, you cannot refresh them. So you always have to go back, and usually you get a session with a security provider, and that allows you then to get yourself another token. And that security token then can be used again just for a set amount of time. So in theory, it also gets quite complicated because you can do things like when that person gets a new token, they also get a response token, which they then have to present with the next time they get that token.
Yeah.
And if somebody else has got it, the man in the middle attack has got it away, then you can actually, because the next response will be that token will be used for getting the next token.
Yeah.
You can validate the whole session.
Yeah. Yeah, it's a really refreshing approach to authentication. Actually, it's really nicely designed and really well thought through. So.
That's the specific problem we've got at the moment, is load balancing the security side, but trying to get the validation of security logged into the servers.
Yeah, that's great. Yeah.
Just trying back to the rest.
Yeah, sure. Yeah.
Or they're all trying to sweep their statement API aside with REST. I can't find anything definitive that says this is what a REST API should look like. With the W3C, or you have that statement connected to these REST.
Yeah.
Very clear.
Yeah.
Is there? I know the sites and stuff. I didn't see anything on there that looked like this is the definitive place you should go for.
No. Yeah. I mean, there's the specification, which is quite long and boring, to be honest. Yeah, exactly. Yeah, I mean, REST is kind of bandied about as a buzzword, to be honest, as well. So a lot of people will use REST kind of incorrectly, if you like. A strict RESTful API is probably something that adheres to the specification, that uses HTTP methods, doesn't use verbs in URLs, all of the things I talked about earlier on in the presentation, really. But actually, a RESTful API, it's very specific to what you're trying to do, what you're trying to model in your data.
Facebook already, they've got like those, because they send
Absolutely.
200 responses for failures.
Yeah.
You can see the body of the request, guaranteed.
Yeah.
Some
Exactly. So this is where you have to be really pragmatic, and you have to look at what consumers you're expecting, what particular application you're going into. I think Facebook's a good example of sending errors as a 200. So they return everything as a 200, or they did do anyway. I don't know if this has changed, but the last time I looked into it, even errors, server errors, whatever, it would just be a 200, and the actual information about what the response is in the body. So the consumer of the API is responsible for inspecting the body and saying, oh, actually that was a server error. And I think they probably do that for that reason, that a lot of API consumers, a lot of devices out there will just balk at anything that isn't a 200 okay. So this way you have to be really pragmatic, and I think, yeah, trying to stick strictly to REST is probably not the best idea. Sorry, in the back, yeah, then I'll come back.
Sometimes you look at the service get in the way, and that's why it's open.
Yeah.
My question is, why did you choose insert 404 when I think you've got pretty good pieces? Because the end of it is not there, so the output is the same.
That's a good question. I guess a delete. So there's this notion of requests being idempotent, which you might have heard of. So this is the idea that if you send a request, you should receive the same response back, no matter what the status of the server is. So that's, I guess, one argument for that. I would argue that if you've deleted the dog, it's no longer there. So the dog with that ID doesn't exist anymore, which is why I return a 404. Yeah. Oh, absolutely. And this is a classic example of like what is REST. You know, what should we do in this situation? And to be perfectly honest, as long as you document quite well what you're doing, then you can kind of do what you like, really. But I think it is quite important to at least adhere at some level to what developers would expect. And REST is kind of the closest thing, away from SOAP and XML RPC. REST is kind of the closest thing to what people might expect. And so sticking to it at a basic level will mean developers don't have to completely learn your API when they turn up. They've got at least a general understanding that, okay, it adheres to some of the principles I've maybe seen before in different APIs. But yeah, there's absolutely loads of these contentious points that you could go either way. Yeah. So yeah.
Yeah, any sort of non-trivial API is going to evolve over time, and you might be clients, there's going to be breaking changes. Is there any sort of best practice for handling versioning of the API? So you can, give a client and say, I'm used to version 3.2 of this API, and I want you to support that even though there's a new version.
That's a really good question, something I didn't actually touch on in the presentation. So I would actually use the URL to version. So I would prefix anything that I'm doing in the URL with a v1 or a v2 or a v3. It's then totally obvious it's in the URL which version this is. Some other people, other people who are building RESTful APIs would advocate to keep it out of the URL because it doesn't really belong in the URL and it should be in a header instead. But I would argue that this is so important that it should be in the URL, it should be up front and center. This is version 1 of the API I'm connected to, this is version 2. The other option, of course, is changing your domain as well. So you could completely change where you're referencing your API to if it's a complete break and change. Yep.
If you're building a service and you're responsible to the API and the client side, go back to the point you made about validation, you need to be identified.
Yep.
Is there any kind of solution other than basically duplicating that validation logic on both sides?
Yeah, so if you're using JavaScript on the server side, so Node.js, and you're using it on the client side, then yes, you can build your validation layer once and share it using technologies such as Browserify, which allows you to expose modules to the browser. You could also use ES6 modules as well, which are supported on both client and server side, at least on newer browsers. And you could use things like Babel to kind of transpile them back down to ES5 as well. So yes, if you're using JavaScript on the client and server, then it's certainly possible. If you're not, then I'm afraid you're going to have to duplicate your business logic. Yeah.
Are there any conventions around fetching different types of data from the same URL? So say one dog, one cat.
Okay. Yeah, I guess you maybe then be fetching animals. So you could change your URL to be animals instead, and you could filter if you wanted to just return dogs. That's one option. You could use different URLs, so you could use an animals URL and then a dogs URL. You could go that way. So yeah, it's all about looking at your data model and kind of designing it appropriately from that. Kind of slightly related to that, but not exactly what you asked, is there are also ways of returning different formats of data as well. So I talked about using JSON, and JSON's a very good idea, but if you have clients that expect XML, then you might also want to return your data in XML. And to do that, you can use suffixes on the URL. So dogs.json, for example, or dogs.xml. Or again, you can use a header to describe what kind of information, what kind of data structure you'd be expecting. Really good for time. Okay, yeah, thanks very much, guys. Thanks for listening. Yeah, I'll be around later if you want to chat some more.
Thanks, Tom. So we're going to take a really short break to talk about the machines, do fill up glasses, and we'll be back in 5 minutes. So, So, if you've got a more complicated object model, so you've got dogs with owners and walks and things like that, are you just returning? Presumably, you're just returning the whole of the hydrated
the
object
data model.
Yeah,
it totally depends, doesn't it? Really, what you want to do. And, again, you can use query string parameters to say return yes with owners, return without owners.
Right.
I think it's quite hard to second guess sometimes what you're